Hello, everyone. Welcome to DevStandup session 14. And today, our guest speaker is Sam Gabrail. Sam is a platform engineer, educator, and founder of TeKanAid Solutions. Sam helps companies building strong internal developer platforms and is known for his practical hands-on teaching in DevOps and platform engineering. Today, he's going to introduce us Crossplane 101, building a self-service internal developer platform on Kubernetes, a session which focuses on how Crossplane turns the Kubernetes into a universal control plane for cloud infrastructure, the components, and how they enable developers self-service without needing a deep AWS or Terraform expertise. I would like to hand over the microphone to Sam and he would kick off the session. So, Sam, here you are.
Thanks, Eleanor. I appreciate you having me here. And today we're just going to talk really briefly on Crossplane because it takes a lot of time to dig deep. I actually have a course on that, so if at any point you're interested in digging deeper, I'll let you know by the end of this where you can find this course. But yes, as Eleanor mentioned, we are going to talk about Crossplane, which is an infrastructure as code tool. So you might have heard of Terraform. Crossplane is similar to that, but it actually runs straight through Kubernetes, and it basically enhances Kubernetes with CRDs to allow you to build infrastructure directly from within Kubernetes. So we'll see how that all works out. So I took this out of my course, and it's just the kind of the introduction to the course to give you an idea of what this is all about, and we'll have a quick demo from the course lab itself to see how we can build something really quickly in AWS using Crossplane. All right, so the course overview, we will talk about building production-ready internal developer platforms. And when you think of an internal developer platform, it's basically a platform that allows developers to easily and quickly do what they need to do. So they might need to create a database in a certain cloud. They might need to spin up a VM or a container. So instead of them having to understand the internals of the infrastructure tools they need, they can leverage an abstraction that can allow them to easily and quickly get to what they want to do very, very easily. So then the technology stack is basically Crossplane, which is an extension to Kubernetes. It runs on Kubernetes, and then it allows us to create some AWS integration and build some resources in AWS. It could be anything else other than AWS. It could be GCP in Google. It could be Azure. It could be on-premises infrastructure as well. So this course has 6 labs that will guide you through and enforcing concept as you go along, how to actually use Crossplane to build that infrastructure, and we have a bunch of quizzes and so on. This is an intermediate skill level course, and it's designed for users with existing Kubernetes knowledge to be able to advance their platform engineering career. Learning objectives, basically what is platform engineering and how does it relate to DevOps? And why am I talking about platform engineering as opposed to DevOps? What's the difference? We'll talk very quickly on that. The Crossplane architecture itself, the different components, the workflows that powers this universal control plane, and then the AWS integration, how do you integrate? And then the composition patterns, how do you build like Lego blocks? And if you've built something before, how do you reuse it in Crossplane? And then production operations, how can we productize this solution and implement GitOps workflows with Crossplane? So some of the prerequisites and requirements is Kubernetes knowledge, so familiarity with pods, deployment services, YAML config, AWS familiarity. You want to know what an AWS VPC is, EC2 instances are, S3, RDS. Some familiarity with the command line, Linux command line specifically, and platform concepts. What is infrastructure as code, the principles, why we run infrastructure as code. And then from a lab perspective, you get all the labs. All you need is a browser. So let's talk about the platform engineering challenge, the traditional problems, how we got to where we are today. And it all starts with slow provisioning. So you might see environments today still using manual setups to create infrastructure, taking weeks, blocking development teams. So what would happen is a developer would ask, hey, I need a VM or I need a database. And then they submit a ticket, and that ticket goes to a database team. A DBA would pick up that ticket, and of course it's going to be in a queue. And then they would go and create that database, whether on premises or in the cloud. So they have to spin up an EC2 instance, for example, in AWS, and then configure the database, get it ready, make sure it has all the governance that is needed for that and security that is needed as per the compliance requirements for the organization. And then pass that ticket over to security. They need to verify that everything looks good. They respond back. And then finally, the developer gets their database. And that could take a week or two even. And that really slows down a developer as they want to move quickly. So these are bottlenecks. The platform team or DevOps team or infrastructure team can get overwhelmed with so many requests, especially that those teams are usually not staffed very well. You get 2 or 3 people depending on the organization. And then you get inconsistency. You might have what we call snowflakes, different, unique databases running all over the place or VMs all over the place. We want a way to standardize all of that. And the way to do that is with self-service infrastructure through platform abstraction that empowers developers while maintaining consistency and control. So we want to make sure that we're allowing our developers to, instead of submitting tickets, they click a button in a portal somewhere that goes behind the scenes, creates the database, make sure it follows all the security practices and all the governance that the organization has in place. Within minutes, they have the database they need, and we move on, right? And that's how we're trying to talk about why platform engineering and how we got here from DevOps. This is what we're going to cover next. Platform engineering fundamentals. So what is platform engineering? So the definition, core principles are very close to DevOps, but there's a spin to it. So platform engineering is the discipline of building and maintaining internal developer platforms that enable self-service infrastructure through abstraction. What does that mean? So we want the developers to be sufficient and have a self-service portal. They just, like I said, put in a few parameters, fill out a form, click a button, they get what they need, right? So it needs to be self-service, and we don't have to worry about submitting tickets and getting the platform engineering or the DevOps team bothered with that. And then we have to enable golden paths, so standardizing well-tested workflows for common tasks. You can't do this 100%, but it's always the 80-20 rule. So most requests will fall under the 80 rule, where you're getting the same request over and over and over again from developers. So you want to make sure you're standardizing those through your internal developer platform. And then abstraction layers. These layers hide complexity while maintaining governance. Like I said before, the developer doesn't need to know how they're building the infrastructure, how that database is coming to them. They don't care. They want to work on features, building features, and they need the infrastructure behind that to support them. And then finally, platform as a product. Treat platforms as products with users and roadmaps. So this is the differentiator between DevOps and platform engineering. DevOps is actually a set of principles and culture. It's not a bunch of tools stitched together. It's not a role in an organization, although you'll find a lot of companies requesting DevOps engineers. It really wasn't meant for that. We've really changed it over time. Like I said, it's a set of principles and having and teaching how developers and operations need to work together, and stop pointing fingers if something is not going well with the developer and the operations also doing the same thing. Maybe developers shipped something that has a problem in the code. They need to work together, need to figure out what the problems are and move from there. So the principles that DevOps brought to us, we are continuing to use for sure. Some of the drawbacks, though, is that there were no specifics into what tools to use. What do you do? So every company was creating their own tools, creating their own processes, and using some of the principles in DevOps, but nothing really concrete in terms of what DevOps is really about. If you walk back in the day when I used to work for Docker, I used to walk in a room and ask, well, can you define DevOps? And if you have 10 people, you get 11 answers, right? So what happens is now we're working towards building platforms that are standardized across the environment with standardized tools instead of having 100 tools. And Eleanor will probably see that quite often, that there's so many tools that a DevOps engineer has to work with. And and every day there's a new tool that comes out, and becomes really a headache to be able to find out what's new and so on. So again, platform engineering, we're trying to build concrete abstraction levels, a concrete platform that can be used as a self-service product for our developers. Actually, which takes me to this last point. Again, I didn't touch on it as much, but platform as a product, making the original DevOps teams actually become product managers. Now they're actually building a product. They have to manage it. They have to understand the needs of the developers. So they have to think and put the thinking hat of a product manager, and not just a DevOps engineer trying to build pipelines and automate things. They're actually building a product for their internal customers, and those developers are their internal customers. So the skill set needs to shift a little bit as they're building those platforms. All right, so that's platform engineering and DevOps in a nutshell, but let's jump into Crossplane. What in the world is Crossplane? It is a universal control plane, and it is built on top of Kubernetes as an add-on that transforms your Kubernetes cluster into a universal control plane for infrastructure management across your clouds, your services, really anything that has a provider that you can use. So the universal control plane is a single API for managing multiple cloud resources. It uses a declarative approach similar to Kubernetes, meaning that I tell it, I want a desired state. I want a VPC in AWS with an S3 bucket, with a database, with certain networking, subnets, and security groups, and all that. I want that to happen. And you submit your request, and then Crossplane behind the scenes goes out and figures out the dependency, what needs to be built before what, and build that out for you in a declarative kind of fashion, similar to what you would do with Terraform. And Kubernetes native, meaning that if you're already a shop, a company that is using Kubernetes, this will be very familiar to you as you're running Crossplane. Crossplane versus traditional IAC or infrastructure as code. So now it's funny because now I'm referring to Terraform as traditional. So far, Terraform is probably the biggest infrastructure as code tool out there that people are using to provision resources. Crossplane is still newer in the market, and it appeals a lot more to people that are already running Kubernetes in their environments. But there are advantages of Crossplane over your traditional Terraform approach. And from a workflow perspective, you see that traditional or Terraform uses specific CLI and pipelines, where Crossplane uses Kubernetes native workflows. From a state perspective, Terraform has a state file, and that's very important to maintain its understanding of the real world, what's in the real world, through this state file, and it's actually a file. Whereas the state in Crossplane is actually stored in the etcd data store inside of Kubernetes itself, inside the Kubernetes cluster. From a drift detection perspective, this could be probably the biggest advantage of Crossplane. From a drift detection, it's limited from Terraform. You have to run another Terraform run to make sure, or Terraform plan to see if there's drift. And what I mean by drift is, if you've built something with an infrastructure as code tool, and then let's say Terraform, and then your colleague in your organization went out and used the AWS console and made changes there. Well, guess what? Now there's drift. Now there is a change that has happened outside of your infrastructure as code tool, causing this drift, which is a problem. So to actually reconcile both of them, you would have to, for Terraform, run a Terraform plan, whereas with Crossplane, it's done in real time using the reconciliation loop that Kubernetes already has. If you're familiar with Kubernetes and you have a pod, for example, and you decide to delete that pod, and that pod was created through a deployment, Kubernetes, through that deployment, will go back and re-spin up that pod. So it does the same thing with infrastructure in this case. From a deployment perspective, you typically use CI/CD pipelines for Terraform, native Kubernetes deployment for Crossplane. The API model is provider specific, and for Crossplane, it's consistent with the Kubernetes APIs. Developer experience, you're required to understand and learn a specific language. Terraform is a language based on HashiCorp configuration language, which is HCL for short. With Crossplane, again, if you're familiar with YAML, you're good to go with Crossplane because of Kubernetes, uses the exact same Kubernetes manifests. From a real-time infrastructure management, so you have live monitoring tools with Kubernetes, the same tools you're used to with Kubernetes you can apply with Crossplane. There's automatic drift detection, as I mentioned. There's self-healing. If an infrastructure failed, for example, it will respin it. Event-driven operations also. So some of the platform engineering benefits, platform engineering teams, they now can reduce operational overhead through automation. They can standardize infrastructure patterns for consistency and built-in security and compliance controls, scalable operations, supporting more teams with fewer people. Development teams, what they benefit is faster time to market. They move much faster. They have self-service infrastructure. They can build whatever they need really quickly. Reduce cognitive load by abstracting complexity. Today, actually, some shops will ask their developers to learn Terraform to be able to spin up their own infrastructure. We want to move away from that. We want to have the developers focus on what they're doing best, and that's shipping features. So if you're a Python developer, you want to focus on Python. I don't want to go worry about HCL or infrastructure. I want to focus on Python. If I'm a front-end developer, I'm working with React or Vue.js or whatever framework I'm using with JavaScript, for example. I don't want to have to worry about learning a whole lot of other tools just to get my application running. Consistent environments across different development stages. So I want an environment that is well tested. I want a development environment and a test environment, a QA environment, and a production environment, of course. And I don't want to have variations, too much variations between those environments. No context switching between different tools and platforms. So here's a success story preview. This is what we want to get to. We want to get to a place where my developer can simply create a YAML file like this. You can see here 1, 2, 3, 4, 5, 6, 7, 8 lines. And from here, all they're doing is that they're saying, hey, I want a Postgres database. So all they're going to say is like database, Postgres. The size is medium, and I want it in the production environment. That's it. They submit this to a platform, and be it Crossplane in this case. Crossplane behind the scenes goes and does all the work for us and creates that database, presents the connection credentials for that database, and that's it. Now the developer has that, and they can move on and work with their application. So this is the goal. This is where we want to end up. Now, whether you use a YAML or you use a form using some other tool like Backstage as a front portal, that's not the issue. We want to make lives easier for our developers. So I'm going to move a little faster here. What is Crossplane? So again, it is a Kubernetes native infrastructure management tool, and it has different components. There's the Crossplane core, and then there are the providers. Think of those as plugins that plug in based on the different external systems that we want to manage. So whether it's AWS, GCP, Azure, other services, and those providers basically talk to the APIs of those different cloud vendors and be able to provision those infrastructure. Then there's something called managed resources, which is Kubernetes' representation of those external cloud resources. So there's going to be a managed resource for an S3 bucket in AWS, one for EC2 in AWS, and so on. Then there's compositions. Think of them as templates that, like I said before, Lego building blocks. I want to make sure that maybe I have a template, a composition for maybe 2 or 3 S3 buckets with a few EC2 instances with a VPC, package them all together as a composition, and then I can always spin all those resources together instead of individual managed resources. They all come in as a package. And then claims, this is on the developer side. They submit a claim. So a claim would be something like this, their request, and that goes out and builds the compositions and the managed resources behind the scenes and away we go. Claims have been actually deprecated in Crossplane 1.x, and I have a whole section on Crossplane 2.0 in the course as well, but I also wanted to put it here in case there are people that are using still Crossplane 1.x. Providers, they're the bridge to external systems. The YAML for it looks something like this, and it basically, like I said, ties your external system to Crossplane. So now we can use this provider to provision EC2 instances, for example, inside of AWS. Manage resources. Now that we have a connection into AWS, now we want to create, let's say, an S3 bucket. We can do so with YAML config like this. So you can see here we're specifying what region. The ACL is private for this S3 bucket, and the provider configuration is this default provider that we created here. And that should go out and spin up the S3 bucket for us. Then there's a composite resource definitions, and think of this as a schema to building a specific thing that we want. In this case, the thing is the database. So we want to create a database with a particular schema, with the Open API version 3 schema as well. And here's where we're saying we can give the option of a particular size for a database, small, medium, large, so that the developer can choose. So we build that schema with something called an XRD. And compositions, that's what I said. We're packaging a bunch of resources together so we can spin them up together. And then finally, like I said, claims allow the developer to submit this claim. For example, this database size medium in the environment production, and that will call on the composition behind the scenes and build everything that we need. And with that, let's jump into our lab. So here we're on the TeKanAid Academy, and we can jump into the Crossplane 101 course and continue learning. I already spun up the lab beforehand, so we don't waste too much time building the lab. So we're in a lab here, and let's see if I can make this a bit bigger. So what this is, it's basically a VM. This is a Linux VM, so you can run a bunch of Linux commands. And I've already gone through a few of these tasks. So every lab has a bunch of tasks. And the first task was just setting up Crossplane and the AWS providers. And then the second task was testing the providers and the authentication. And then the third task, which is what we're in right now, I did run it beforehand just to make sure it's working still and everything is good. But it is good, and now we can go through real quick and show you how we can create a VPC and some networking infrastructure inside of AWS. And the lab also spins up an AWS account that is TeKanAid's AWS account. I'm not asking you to spend money on AWS. This is all behind the scenes done for you through TeKanAid's own AWS infrastructure. So you're not paying for anything here. And then we can sign in. And you can see that we have AWS right here. We can go into VPCs. And I want to show you that right now there is no VPC created other than the default VPC that comes with AWS. So we're going to go ahead and run through steps 2 to the end. And you can see you can review the VPC manifest under the platform VPC file here. So if you go here and look at this, this is what the platform engineer would build on behalf of the developer. So you can see here the API version, the kind is VPC, some metadata, what environment we're building this in, development environment, and the purpose, the IP CIDR block that we're going to use in what region, and so on and so forth, some tags as well. So based on that, since we've written this YAML file, we just need to apply it into Kubernetes like this. And what this is going to do is going to create the VPC for us in AWS. So if you give it a minute or so. Okay, looks like it is done. And there we go. This command, kubectl get VPC, shows us that this VPC called platform VPC is synced and is ready to go. And it gives it the unique identifier for that VPC inside of AWS. So now if I go into AWS and refresh, I see that here's my platform VPC that we just created, and that got created automatically for me from within Kubernetes using my Crossplane, right? And we can continue on and on. We can create now an internal gateway, run that. And I'm not going to wait for the condition. Let it bake here. I'm going to run the public subnets. Let that run as well. I'm going to run private subnets. And as you notice, we are telling it this is our desired state. So go out and generate this for us. And I don't care how you do it. Crossplane takes care of that for me. Configuring some security groups. So all this is necessary from a networking perspective to get to a point where we actually create a database. We're not building a database in this particular lab. In a future lab, we'll build a database, but you need the underlying infrastructure for the database to finally be created. All right, so let's see if this infrastructure is done. So let's clear out of here, run the VPC. We already saw that is complete. Let's see if the subnets are complete. Subnets are all complete. You can see they're true. They've been created. Let's see the subnet. The security groups are also created. And what else? Security group rules. These are also created. So if we go into AWS, you can see the subnets. Here we are. The private subnet A, B, and public subnets A and B have been created. The internet gateway has been created. This allows us to go out to the internet from our local cloud, the virtual private cloud that we created, the VPC. And what else? Security groups. We created some security groups, so you can refresh that. I see two of my security groups, one for web, one for app. And for each one of these, we definitely have a security group rule as well. So you can see this is the security group rule allowing port 8080 to come in. And that's it. As you can see, these are all created via manifests. So for example, I showed you the VPC manifest. This is the Internet Gateway manifest as well. So this is what got deployed. And this is the EC2 provider that we connect to. So this allows Crossplane to connect to AWS. And then there's the provider config, which is a secret allowing us to connect with credentials into AWS, because Crossplane needs to authenticate into AWS to be able to provision all my subnets here. You can see public and private security group rules and security groups. Okay. So what we built right now is all managed resources. We did it one by one. You wouldn't do this in production. You would have a composition that actually builds all of that together at once. And then that is actually called from a claim that the user, that the developer asks for with those 3-4 lines I showed you, and that will go out and build the entire infrastructure for us. I just wanted to show you a very quick and simple demo to get you to understand what Crossplane is all about and how it can provision infrastructure for us. And that's all for today. I hope this is helpful.
Yeah, Sam, thanks a lot. First of all, I would like to mention that it was really interesting, like the labs and the theoretical part, and also luckily that we did this session not on Monday, because I see that you are deploying this USD Swan zone, so we will have a lot of problems. So yeah, it's
Good point.
Yeah, we did like on Wednesday. So yeah, I will just pass this microphone to Atakan to ask you a couple of questions, then I will ask my own questions. So Atakan, you can.
Yeah, it was a very interesting topic. Like, I just had a question. Like, is it possible to, in Terraform, you can have the Terraform set up the cluster. So since it's using etcd, is it possible for the Crossplane to also like set up its cluster, then start adding the things? But like,
great point. So you're asking, you're asking a really good question. The bootstrap problem, like how do we set up the Kubernetes cluster that's actually going to be the control plane for building everything else?
Yeah, also the state itself. Yeah,
exactly. No, great question. So typically you build something with we build that with Terraform, right? That would be their starting state, and from that point on, it's going to be Crossplane from that point forward. You can obviously create that cluster with Cluster API or any other kind of tool that you're used to with Kubernetes. Every organization, every company will have their own method of building clusters, but Terraform is definitely a viable option to use. I wouldn't recommend you going and clicking inside of a GCP UI to build a GKE cluster. Um, I've heard some people mention, I'm not a fan of this opinion, is that you can actually build a cluster and then bring it into Crossplane's own management, so it's managing its own cluster. But then you could run into a problem where something happens to the state and that cluster is in a bad state, and then all your resources that you've built through that cluster is suffering. So you don't want to do that. You want to separate that as its own cluster for building resources. Great question.
Yeah, thank you.
Yeah.
This platform tools are really near and dear to my heart. So it's like every day pretty much I'm using them. I have like a couple of questions. This Crossplane reminded me a bit of Argo CD. I don't know if you have used that or not. For example, let's say if developer does something, it automatically declaratively sees the syncs, everything like from the code, and then like starts like doing same thing in the environment.
Yes. No, great observation. So yeah, if you go back and look at the lab, I have a whole section on GitOps with Argo CD and Crossplane. They
Yeah.
work very well together, and I have a whole lab on this one of my favorite labs here. GitOps with Crossplane, where we show you how to use Argo CD, and this is actually how you should use it in production. So Argo CD is going to be the actual mechanism that the platform engineers are going to create those manifests, those Kubernetes manifests, store them in a GitHub repository or whatever Git repository you're using that is monitored by Argo CD, and Argo CD behind the scenes is the one that's going to go out and deploy that. So that's exactly what we do in this lab. Yeah. So great question, Elner, and that's the way you should do it in production.
Yeah, this Argo CD, this both kind of combo would be really nice. I had a question regarding this Crossplane also. Did I understand correctly that it only supports for the infrastructure, like let's say Azure, Google Cloud? For example, let's say in Terraform, I can also do some I don't know, code related stuff for the Cloudflare or Vault, so I can manage also those resources. Is it only cloud specific, or it also supports like multiple providers?
It supports multiple providers, and it even goes further than Terraform, and actually can do things with applications themselves as well. So yeah, so as long as the provider is there, so you can look up Crossplane Marketplace. So Crossplane, by the way, is backed by a company called Upbound. And browse packages, providers, configurations. So they have their own marketplace, kind of like the Terraform registry.
Okay.
So you can find, you said Cloudflare.
Mm-hmm.
Let's see. They might not have it under here. Let's see if they have it here. Configurations. I don't think they have Cloudflare. What else did you ask for?
Maybe Vault.
Vault. Yeah. And to be honest with you, they actually have. I'm not sure why nothing is showing up here. That's odd. There it is.
Yeah, this one.
They actually, under the hood, sometimes they're actually using Terraform under the hood in some instances. So that's how they're enabled, or that's how they're able to tie into a lot of the Terraform providers that have already been used, right? So there's something called Terraform Jet, I think is what they call it. I'm surprised they don't have Cloudflare though. That's something for Cloudflare to figure out, because they should have it. Yeah, so you use something called Terraform Jet as well under the hood that you can find, where they can pretty much use Terraform for anything they need, right? But as you can see, there's Datadog, the GitHub as well, and maybe you guys can build something. I mean, this is obviously open source. You can build those.
Pretty much.
Yeah. Exactly.
Also, what's your kind of take? Like, is it like ideal using the hybrid solution like Terraform and Crossplane, or solely moving to Crossplane in your like ideal
Yeah.
platform engineering world?
Yeah, like I said in the beginning, the Terraform is the king of infrastructure as code today, right? So today, as we stand, you'll find Terraform in a lot more organizations than Crossplane. However, that said, Crossplane really appeals to organizations that have Kubernetes, that are very good with Kubernetes. They will tend to drift towards Kubernetes and use Kubernetes, use Crossplane with their Kubernetes install. So that's kind of where it is. Using both obviously works, right? And in bigger organizations, you'll be surprised that you'll find that there isn't necessarily always standardization in tools. So you'll have some teams using Terraform and maybe a few teams using Crossplane, right? That also happens. So it's not a one or the other. They could be both in the same organization as well. But like I said, Terraform is definitely the king out there today.
Mm-hmm. And the last question is gonna be, let's say if the company or the organization would like to migrate their Terraform codes into Crossplane, how painful is the migration process? This HCL to basically YAML.
Yeah. I mean, it's definitely much easier now with AI, right? But at the same time, it's not straightforward. There's no easy button that you can just go out and create. So it will take time. It takes significant effort. But I always say when you're approaching a project like that, always start with an MVP. So a team that's willing to go out and use Crossplane, and that team will typically have certain Terraform modules or certain Terraform configuration. So they can focus on one or two of that, migrate it over, test it. It looks good. Then we move on to the next phase. And once that team has migrated over, then we look at the next team and so on and so forth. So it's your typical migration strategy. There is no easy button today to do that, but yeah, it definitely will take some effort. Yeah.
All right, Sam. Thanks a lot. I really appreciate the answers, and I hope that there will be like some people also haven't heard about this crossplane as I didn't before, and yeah, I hope that it will be also useful for them. And guys,
Yeah.
yeah, that was it. Our Dev Stand Up session 14. Yeah, thanks, special thanks for the Sam for presenting this really nice session with us. And if you would like to be our next guest speaker, please fill in the form under the description below. Our team will contact you, and then we can schedule our next Dev Stand Up with you. Apart from that, have a nice evening, guys, and see you in our next Dev Stand Up. Bye bye. See you.
Thanks, everyone.
Yeah.